8-9, solving systems of equations. You can solve a system of equations by graphing each equation separately. The solution to the system is where the two lines cross. So when we talk about solving a system of equations, we're simply talking about where these two lines, x plus y equals 6 and y equals x, where they cross each other. So the first thing we want to do is actually put both of those lines on the graph. First, let's put y equals x on a graph. So we need to know the slope and the y-intercept for this line, for y equals x. All right, so there's no number next to the x. In reality, there's a what? Yes, there's a 1. So the slope of this line is 1. And the y-intercept, well, there's no plus anything or minus anything. What do you think is going to be the y-intercept? That's true. It's going to be 0. So this line is going to be y-intercept of 0 and a slope of 1. So we can actually put that on the graph. Y-intercept is 0 and a slope is 1. And we can put that on the graph just like this. And then I will draw this line in blue so that we have it. So there's our blue line. Put the little arrows on the end. So now we will also put x plus y equals 6 on the graph. We have to change this around so it's in slope-intercept form. Subtracting the x from both sides. Y equals 6 minus x. Still not there yet. Manipulate it a little bit. Y equals negative x plus 6. So from this, we will also get the slope and the y-intercept. For this equation, its slope is negative 1 because of the negative sign, and there's no number next to the x. It's a 1. And the y-intercept is positive 6. So we'll put this line on the graph, go up to positive 6, put our y-intercept, and our slope is down 1 over 1 to the right, down 1 over 1 to the right. And then I will continue, and I will put that on the graph as well. And the line didn't go on very well. They actually should have crossed right there. And the solution is where those two lines, the red line and the blue line, where they cross each other. And the coordinates of that point are 3, 3. So this is the solution to that equation. They cross each other at 3, 3. So, solving systems of equations by graphing. This is one way. This is not a very exact way of finding the solution. You can obviously see that it's not exact because my red line isn't on the graph where it's supposed to be. It's a little up to the right and up to the right a little bit. So it's not exact. It's a good approximation. It's not exact. I will show you in a few minutes a more exact way of finding the answer. But first, I want to explore what happens with the solution, the systems of equations. Here, how many solutions are there with a pair of intersecting lines? We have one line that's with a positive slope from left to right, and it intersects with a horizontal line. How many solutions does this system of equations have? It has one. Because these two lines only cross each other in one place on the graph. You could extend these lines on forever in all four directions, and they would never cross each other again. That's the only place they intersect. Okay? How about these two parallel lines? How many solutions do these parallel lines have? In other words, how many places do these two lines cross each other? You're right, they don't. So parallel lines have no solutions. And finally, how many solutions are there if both equations are for the same line? So I've drawn them separately, but I'm actually going to move one line down on top of the other line. So once I place this second line on top of the first line like this, how many solutions do these two lines have? The way we call this, we say these have an infinite And we say that they're infinite solutions because every single point on one line is the exact same point on its corresponding line. So they have an infinite number of solutions. So graphing systems of equations, not very exact. You get a good approximation, and you can see from graphing solutions that you can have one solution, you can have no solutions for parallel lines, and finally you can have an infinite number of solutions for the same line lying on top of itself. Now, a more exact way of solving a system of equations is to use something called substitution. We are going to use information from one equation and substitute it into the other equation to find one of the coordinates, and then we will work backwards to find the other coordinate. So we're going to find an x and a y, the coordinates of where they cross each other. So we have two equations, 2x plus 3y equals 5, and y equals x. We're going to use the y equals x as the equation that we're going to use to substitute into the other one because it's a simple equation. We know that in y equals x, in that equation, we know that the variable y equals the variable x all the time. So we're going to substitute that into the first equation. So if we have 2x plus 3y equals 5, we're going to substitute in y equals x. 2x plus 3x equals 5. We substituted in the x for the y from this equation. Now we will simplify it. 2x plus 3x is 5x equals 5. Divide both sides, or each individual item, by 5. And we know that x is equal to 1. That's the x coordinate where these two lines intersect each other. Now we need to find the y coordinate. You can choose either equation you want to solve to find out what the y coordinate is going to be. It's entirely up to you. But I have some advice. Always pick the equation that has the least amount of math or what looks like the easiest amount of math to you. So we have 2x plus 3y equals 5, or we have y equals x. The choice is yours. I will choose y equals x because it's easier. And we will substitute in y equals x. We will substitute in 1 for the x, and we know that y equals 1. So the solution to 2x plus 3y equals 5 and y equals x is 1, 1. That is where these two lines cross each other. That is the solution to this system of equations. And it is very exact. You don't have to decide if one line is up or off or whatever. It's exactly the solution where those two lines cross each other, unlike the first example we did where it wasn't quite exact. Your homework is on page 417, problems 10 through 26, the evens.